Let's start with a brain teaser. Suppose there are 15 students and 8 of them play handball, 5 play football, and 5 don't play either handball or football. At first there might seem to be a contradiction here. 8 plus 5 plus 5 equals 18, not 15. Where have the extra 3 students come from? Well, if you think about this for a bit, or if you've come across these sort of problems before, you'll see the solution. It's not that we have 3 extra students, it's that we've double counted 3 of them. We've counted 3 of them twice. Why is that? Because 3 of them play both handball and football. So if we take that into account, things then work out. And there's a really nice way of showing this information in pictorial form. The simple tool we use for this is called a Venn diagram. We draw one circle to represent those who play handball, the H circle, the blue one. Another one for those who play football, and we label that F. It's important to label our circles in a Venn diagram so we know what we're talking about. And then there are some who play both. We overlap the circles then. So the green and the blue overlap. And that's it. Well, not quite. We put all this information inside the black rectangle that I've already drawn there, and usually in the top left corner we write U to stand for the universal set, meaning that everyone or everything in the study is somewhere in this rectangle, either in the separate part of the blue circle, the part that doesn't overlap, or the separate part of the green circle, the part of the green that doesn't overlap, or the overlapping parts, or else right outside the circles, in the outside part of the rectangle. That's the universal set. Everything in the study will be somewhere in the rectangle. Okay, now let's put the numbers in here to make it more informative. The easiest one is the one that was right outside the circles, because anywhere out here we can write the number who do not play handball or football. This was 5. 5 played neither, so we can put a 5 anywhere outside the circles. Now that means we've reduced the problem. We started with 15 students. We've already put 5 of them in the rectangle in the universal set, so that reduces it to 10 students. And now 8 of them play handball, 5 of them play football. We've already worked out how many play both. That was 3. So we put 3 in the overlapping bit. Now we have to work out the last 2 bits of the diagram. Firstly, how many are in the blue circle by itself, not in the overlapping bit at all, not in common with the green. How many are in the blue only? They only play handball, but not football as well. Well, we found that 3 are playing both. If 8 played handball, 3 are playing both. That must leave 5 play handball only. Similarly, 5 were playing football, a total of 5. 3 of them play handball as well. That must mean only 2 play football by itself. And there we have it. There's all the information. And if we add all the numbers up, 5 plus 3 plus 2 plus 5, we get 15. Everybody in the study is represented on this Venn diagram. Venn diagrams are also very useful for working out probabilities. The probability of something happening is just the number of ways that something can happen divided by the total number of ways anything can happen. Or that's often put in a slightly more condensed way. The probability of something happening equals the number of successful outcomes over the total number of possible outcomes. So for example, what's the probability if I select someone at random from these 15 students, what's the probability that they play neither handball nor football? Well, how many successful outcomes would be there? There's 5 possibilities. 5 students don't play either. So it's the successful outcomes, number of successful possibilities is 5. The total number in the study is 15. Total number of outcomes, 15 possibilities. So the probability of one person that I select at random not playing either handball or football would be 5 divided by 15. Okay, let's do a couple more examples then and write them down here. What's the probability, and this is how we write probability in a nice condensed way, big P, and then in brackets whatever it is we want to find the probability of. So when we're talking about probability, if you see a big P, it's just meaning find the probability of whatever's in the brackets. So the probability that someone plays handball only. Well, we need the number, total number who are playing handball only. We divide that by the total number in the study. How many played handball only? We look at our Venn diagram. We see the part of it there that's handball only is got the 5 in it. The part of the blue circle that with no overlapping. There's 5 members in there, 5 students in there. So the probability of this will be 5 over 15. The same probability as the number who didn't play anything because there was also 5 of them. Now another different one. What's the probability that somebody plays both? Well, we just do the same sort of thing. We find the number who are playing both because that's now our success. How many play both? We look in the Venn diagram at the overlapping part. 3 of them are playing both. So the probability of selecting someone at random who plays both will be 3 out of the total number, 15. And of course you should simplify those fractions. The 5 over 15 should become 1/3. The 3 over 15 should become 1/5, and so on. You'll get very good at doing these Venn diagrams. You'll be able to do more complicated ones with 3 circles. You can go up and keep going up forever, but we will probably only be using a maximum of 3. But just to close off this introduction to Venn diagrams, one word of warning, make sure you draw large Venn diagrams. Get into the habit, even when they're simple ones like this one, make them large, make them big. Otherwise you're going to get into huge problems if you do small ones, particularly if you've got 3 circles overlapping in different places. It just becomes a total mess and very difficult to use. Do yourselves a favour, draw nice large Venn diagrams and enjoy finding probabilities from this lovely, simple but very easy to use tool.